Dámy a pánové, já jsem Sara Polak a vítejte u druhého dne COFITu. Včera jsme měli velmi záživý den, probírali jsme paralelní výpočty, probírali jsme image processing, probírali jsme budoucnost umělé inteligence, takže jsme začali tak velmi zlehka. Ale dneska budeme pokračovat dalším velmi nabitým programem, dokonce nás čekají talky 4 a první z nich je talk, na který se velmi těším, na embedded security. Čeká nás expoze laboratoře RFID, kterou vede pan inženýr Jiří Dostál Ph.D., který bude první pár na holení v tomto bloku. Potom nás čeká Ondřej Holeček z Pure Storage, z TrueCrypt Audit and Internals a nakonec z AMI Lukáš Kraus, Access Management a delegovaná autentizace. Já bych jenom moc ráda připomněla, že tady máme Together platformu. Včera se těšila opravdu velkému využití, jsou tam samozřejmě nejenom stánky, je tam kafe, je celý foyer prostě vybudovaný ve 3D, takže aby se vám tolik nestýskalo po vaší domovské univerzitě. Zatím největší jako use case, tak tam byly veřejné záchodky, tak se vám tam přidali video splachování, abyste tam měli jako velkou legraci, ale nebojte se to využívat tu platformu i k jiným účelům, jako například networkování s firmami. Naši komerční partneři tak tam mají stánky, takže určitě se za nimi běžte podívat, oni budou moc rádi. A potom, když budete chtít mít nějakou návaznou konverzaci například s HR odděleními, tak hupsněte rovnou do Slacku a tam už se s nimi můžete domluvit one-on-one. Využívejte to, je to samozřejmě všechno zdarma, přístupné všem, takže si tam choďte, užívejte. A dnes nás tady čekají talky 4, jak už jsem říkala, začínáme embedded security, potom v 1 hodinu nás čeká monitorování síťového provozu a IoT, robotika a embedded systémy, ve 3 hodiny počítačová grafika, gaming, VR a AR, a nakonec to zakončíme Python's Flying Circus a programovací jazyky. Takže to máme opravdu nabité. Já už to nechci v žádném případě zdržovat. Jen pro ty, co se dneska dívají poprvé, tak když uslyšíte jakousi schizofrenii angličtiny a češtiny, tak si z toho nic nedělejte, nezbláznili jste se, ale zbláznila jsem se já, protože si říkáme, že chceme trošku ten náš český talent dostat do globálního éteru. A bohužel celý svět nemluví česky, takže občas to prostě si musíme střihnout v angličtině. Takže například dneska tak hned v tom prvním bloku 2 talky tak budou v angličtině. Potom, až skončí COFIT, tak uděláme nějaký hezký postprocessing, všechno to tak hezky zabalíme a do českých videí třeba dodáme anglické titulky, nebo se nechci úplně nějak zavazovat, ale uvidíme, co s tím uděláme. Už cítím v zákulisí, jak si David Pešek a Pavel Kordík klepou na hlavu, co zase čeká za práci, ale nějak to zpracujeme, aby to bylo bilinguální. Každopádně já už teďka přepnu do angličtiny, abych tady uvítala Jirku Dostála. Jiří, hi, it's a great honor to have you here to kick off the second day of COFIT with a talk on embedded security. Your lab, I remember from last year we were talking about it a lot. You deal a lot with contactless technologies when it comes to various chip cards, but also all the related themes. For example, like the PUF and TRNG generators and all of these security chips and all of that wonderful ecosystem of both hardware and software that it means to create an embedded system and to add that layer of security and encryption and protection for the data and all the technology that we deal with. It's all very well to have sexy tech, but then it needs to be secure somehow and needs to run in a reliable way. And your lab has been doing amazing work on that front to secure secure communications. So I will stop my spiel there and hand over to you. We're very much looking forward to it. To all the students watching, if you've got any questions, don't be shy. We're on the main COFIT stage on the Together platform. Ask questions because you have a unique opportunity to quiz the gentleman on the panel. So Jiří, over to you, and thank you for being with us this morning.
Yes, sir. Thank you for a nice interaction. Yeah, that's true. Embedded security or cybersecurity, and more precisely, embedded security is a big topic nowadays because everything is transferring to the Internet of Things domain. And you know, nearly every single small, I don't know, wristwatches, consumer appliance at home, automotive, cars, etc. Have embedded systems, and that means there are a lot of firmware, a lot of functionalities that needs to be monitored and updated, and that brings a lot of attack surface for these appliances. So from our perspective, and I'm a member of Department of Information Technology on our faculty, and our research and lectures are not only limited to RFID, because RFID is one of the prominent technology. There are, you mentioned it, there are several ID tags, bank cards, mobile phones, near-field communication, etc., and that makes a lot of visible interfaces in terms of radio frequency. So you are, let's say, every single man is like a walking attacking target for the attackers. So that's one main concern. On our faculty or Department of Information Technology, we are not only dealing with RFID technology, but also with embedded hardware and hardware itself. So we have several courses that are focused on hardware security, RFID, ethical hacking, and secure code and the firmware deployment. So as you can see, and we have here in this session several guests that are representatives of companies that are dealing with embedded systems or cybersecurity. So it's a very big topic, and together, for example, with 5G and overall, let's say, cloud security, I would say it's top 3 topics nowadays, and we have to somehow deal with it. So this was my short, let's say, introduction talk, and maybe we can discuss it a little bit later. Or Sarah, what do you think?
Yeah, that sounds great. I've got a lot of questions, but I always have a lot of questions. Maybe one that I would like to ask is, I've read a report recently. I think it was, I don't think Forbes did the report, but Forbes definitely made the article, as they always do. And they wrote about like a 60% rise in ethical hacking during the time of COVID. That a lot of hackers, like traditionally hackers, actually like sign themselves up to various like ethical hacking communities, and they're trying to use this way of testing whether systems are secure enough, like systems of hospitals, so various penetration tests, but also to actually solve problems through untraditional ways, because the big myth is that a hacker is someone bad, but actually it can be someone who just gets to the solution faster through unconventional methods. So I wanted to ask on the subject of ethical hacking, if your lab deals with that, and maybe like penetration testing as well, and what your relationship towards that is.
Yeah, that's pretty good questions. Our lab is involved mainly in teaching students how to deal with the ethical hacking. So that means we are not actually testing anything. We're just actually testing, let's say homework targets or something like that, and not actual system in production. Yeah, because it's a little bit harder to go with, let's say, a legal way, because there are multiple parties involved and multiple jurisdictions, and that's pretty tough. So in the field of ethical hacking, there are several bug bounty programs. So you can just sign up in these programs and try to ethical hack some systems, and maybe you will receive some bounty money. Yeah, so that's one of way how to ethical hackings are working and another way how to ethical hack, it's do it let's say do it yourself. Yeah. So for example, you have your for example, I don't know, eShop for some electronic devices, yeah, and you just see that there is some technical issue, so you can write directly to the owner. You mentioned that in these times of COVID, there are several attacks, more precisely ransomware attacks on hospitals and healthcare at all. So it's like because of spread of COVID and let's say the health system is pretty overloaded, and the money is sent mainly on let's say treatment of people, not treatment of the information system. So there is pretty huge attack surface. That means I don't want to say they don't care about cybersecurity, but they have limited means of cybersecurity. And that's pretty prominent because a lot of healthcare devices and computers are connected to the internet because of collecting data, and that brings a new attack space for the attackers. So that's a huge topic and issue.
Yeah, and you're completely right. We discussed this yesterday as well with a lot of the legacy systems and just old, outdated tech that was cool 10 years ago, but now is like a piece of junk. But it would take a lot of effort and administrative procedures to even begin changing it. I bet that only increases the attack surface. And actually on that front, what do you think is the biggest threat to embedded systems right now? Is it like software-based or network-based or side-based attacks, is there a particular area that's become more active that you have to ramp up embedded security for?
Thank you for your point. I would say the life cycle management, because you said, yeah, it's like 10 years working and now it's a piece of crap. Yeah, that's true. And there are millions or tens of millions devices that are at the end of their life cycle. They are unintended. They are running somewhere without any attention. Yeah, so that's my huge concern, and I do some little research on that. Also, here is another concern about, and that is related to the lifecycle management. So firmware updates and secure connection between it, and also, for example, more technically PKI. So public infrastructure because of certificates expiration and so on. The other main concern is about intellectual property. Yeah, because if you develop a firmware of IoT device or embedded system, it's just located inside the chip, and if you just solder it out and read memories or using JTAG connectors, so you can easily, in 95%, you can easily extract the information, and you can disassemble the firmware, and for example, you have a clue how the system works inside in terms of not only in terms of cybersecurity, but that's another huge concern about IoT security. And the third, I would say, it's like it's not confidentiality of the device itself, but it's like a privacy of the owner. Yeah, because the IoT devices or embedded systems are spread over the world, and you can track the movement of every single people. So that's pretty just. I would say it's there are three concerns about embedded system security, or the most prominent. So privacy, confidentiality, intellectual property, and lifecycle management from my perspective.
Thank you. And you actually, I have one more question, if you don't mind. I told you I have a lot of questions. And this one is about, you mentioned the whole world, and I know that I have a few friends maybe who don't have a technical background who'll be watching this, and my mom wanted to watch this. So maybe for the general public that is excited about COFIT, if you could tell the power of embedded systems, or how they're different and what they are, and also maybe the kind of main mistakes that you see average people making, and that doesn't necessarily have to be a I don't know, a grandmother who puts her password and sticks it on the back of her phone. It can be like, I often see like highly educated decision makers who don't, or big state institutions who don't have their data secured in a proper way. And obviously all of that's fine unless you get into a time of crisis where, and unless like there's a lot more data collected. Like I read that there's 25 times more data now at the start of this decade, at the start of last decade. So the world is becoming digitalized. Security is becoming much more important. So the question has two parts. First, what the hell is embedded security for those people watching? And secondly, what do you think are the biggest mistakes that people are making right now when it comes to it?
So generally speaking, embedded systems are embedded system is any piece of hardware that is embedded, so that's the term, into whatever. So for example, your fridge, your car, your, I don't know, your smart home, or not only your smart home, just embedded system, it's something like in your mobile phone or in that smart car that is located in the mobile phone, for example, for in a SIM card. So that's the definition of the embedded system. And after many years that embedded system it's consisted from microprocessor memories, and it was pretty expensive to embed something like that in, for example, car and refrigerator. But after years it becomes cheaper and cheaper. So that's the reason, and it's pretty easy for the manufacturers to add something smart into any piece of hardware, and have some nice features like to be constantly updated, etc. So that's the reason why we have embedded systems, and embedded system maybe also control systems. So that's the definition. The second part, it's a little bit tricky because I think it needs wide education of people. Yeah, that's because a lot of people treat this system like something like IT, and I don't know IT at all. So that's the biggest issue, I would say. So maybe some TV shows like driving safely or something like that. So be connected safely, or treat your information as your property. So
that's a good point. I will create a cheesy show on how to, ladies and gentlemen, like, Horst Fuchs from teleshopping. But no, you're completely right. It's all about education. And when we've launched elements of AI and in Czech, and we hope that like basically just educating people about the data flow will be a good first step to understand that, like, you wouldn't give a random person on the street your debit card and say, oh yeah, I trust you not to use it, and walk away, like, obviously. But people like say, accept cookies, and they don't think about it for a second.
That's it.
Yeah, exactly. Cool. So education is the way forward. I like it. And actually I have one last question, very quick, visionary question. And I know we were discussing this with David when we were prepping for COFIT. Where would you like to see your lab in 5 years? Or what's like the biggest, like, next research stage you'd like to get to, or like a big problem that you'd like to crack?
Yes, so with our colleagues, we are focusing on multiple areas: RFID cards itself, embedded systems itself, software-defined radios, which is connected to embedded system or radio communication, because you can easily simulate whatever radio frequency protocol. So that's, for example, my area of interest. And my colleagues are also working on research about physically unclonable functions, which are some properties of hardware, to fingerprint the hardware and generating encryption keys securely. So that's, I would say, that's the direction of our laboratory.
That sounds great. And we'll be here to witness all of that with the consequent like 15 COFITs. So I'll always ask you this question and ad infinitum.
And 5G, of course. Yeah.
Oh, of course, yes. Absolutely. Thank you so much, Jiří. That was a great intro and an overview of the topic, as well as some very specific advice and explanations. So thank you very much for that. And thank you for all the work that your lab is doing. Now I'd like to shift to Pure Storage and Ondřej Holeček, who'll be talking about TrueCrypt. TrueCrypt is a fantastic kind of cross-platform encryption service that was discontinued for various reasons. So I'm really looking forward to the audit of that and how that went and the politics around it, but also like whether it was actually safe to use in the first place. So Ondřej, I will hand over to you. It is all yours. And thank you, Jiří, again.
So hello, everybody. I am Ondřej Holeček, actually working in Pure Storage. And yesterday you may heard a tech talk from my colleague Greg Bush. And he actually mentioned that we in Pure Storage have a tradition that every second week, or yeah, probably a second week, as I remember, one of the volunteers from our employees have a tech talk. And on this tech talk, we actually speak about something we like, we learned, or something new. And this is actually the same case as Greg's. But unfortunately, I have just much shorter time today, so I have to reduce my talk a little bit. So this is why I called my talk TrueCrypt Reduced. So what I'm going to talk about is the TrueCrypt. And actually, TrueCrypt has a quite wild history. Very first release was in 2004. And I don't want to spend a lot of time about history. I would like to aim on technical things. But just quickly, the authors are basically unknown, or at least we don't know their email addresses or even their LinkedIn profiles, but they are probably Czechs. And what was quite interesting that in 2014, something very weird happened, and official TrueCrypt page turned to something like this. It was really weird because this is just a warning that we should not use TrueCrypt since it's not safe, and we should switch to BitLocker. And this was really weird, and people naturally started shouting for TrueCrypt verification. They wanted to verify if the TrueCrypt is really that unsecure as the page claimed. So it was crowdfunded and audit was paid, and actually people managed to collect about $46,000. I think it was even more because there were two crowdfunding pages, but second one is not available. So it was something about $50,000. But yeah, I think for now it's not that important. But you can read those audits on that links. I think I will talk about it later. And now I'm quite eager to talk about TrueCrypt internals and how it actually works. So let's talk a little bit about how disk encryption works in general. So let's say this is your hard drive, and when you install any encryption on that, like TrueCrypt, or even you can imagine any other encryption tools like BitLocker or Lux on Linux, it obviously will have a header which will contain the metadata like master key, which is encrypted by your password. Because actually, obviously, if you want to change your password, you don't want to re-encrypt your hard drive. So you just re-encrypt the master key. And the master key is actually used to encrypt your data. It contains other metadata like volume size, used hashes and ciphers. The next part is the most important part, which is your data. And for instance, it can contain something secret like the manual how to make the nuke. And sometimes it contains a tail, which is at the end of the hard drive some important data. I will talk about this tail later. And this is the format of actual TrueCrypt container. It contains surprisingly 2 headers. And this is quite unique because you can, if you are caught by authorities and you are asked to reveal your password, it could be quite a big problem because you can be tortured, and you actually don't want to reveal your password and to show your data to the authorities. So this is how TrueCrypt solved that. And TrueCrypt creates 2 headers. And first header is like it points to well, it contains the one master key, and second header contains another master key, but the second master key is valid for data which starts somewhere after the.
By the way, Ondřej, yeah. I'm really sorry to interrupt, but did you forget to share your screen?
Oh my God.
I just realized, I thought that you were like introducing the topic, and then I realized that you may have forgotten to share your screen. That's totally fine. Don't worry, we will put your presentation online afterwards. And you were talking so beautifully that we already actually have 2 questions from the audience. So don't let it throw you, take your time and carry on.
I'm sorry, because I'm quite in pressure because I realized my presentation is quite long.
That's no problem. Take your time.
Okay, no problem. Thank you. So actually, it's quite important from just from this slide. So this is the header, your data, how to make a nuke, and the tail. And the second slide shows how the TrueCrypt stores your data. And when you look at this slide, this actually describes how TrueCrypt decrypt your data. So for every combination of, I forgot to mention that TrueCrypt supports many hash functions and many ciphers. So to choose the proper cipher, when TrueCrypt tries to decrypt your data, it actually does it like this. It takes every combination of hash and cipher and cipher algorithm and derives the key from salt and password and try to decrypt the header 1. So since there are about 5 cipher algorithms or even 10 cipher algorithms and I think 4 hash functions, it may take a while, in probably a couple of seconds, to try all those combinations. And if it succeeds, then it just mounts your hard drive. And if it doesn't succeed, it will try the second header. And it will repeat the same with second header. And if it succeeds, it mounts your data with second header. If not, it just rejects your password. So what it means? So on this slide, you may see that if it successfully mounts your data with the first header, you will see something you put to your drive just to confuse the authorities. I would suggest you to put something which looks like a secret, but it's not the real secret. So, for instance, your wife naked, and I think it may satisfy those authorities, but actual real secret data would be pointed by the second header, and since everything which is encrypted looks like random data, there is no way how they can prove you that there is actually a second header. Yeah, because if there is no second header, then it would appear like random data. Yeah, and how TrueCrypt realized that you actually entered the correct password? So first it checks the header consistency. So so it checks the magic, which is vera or true, 4 bytes at the beginning of the header. VeraCrypt is actually the new version of TrueCrypt. I will talk about it later. It will check CRC checksums and some values consistency. Now, I would like to talk a little bit about implementation. So implementation, if you want to implement your own disk encryptor, you will surprisingly realize that it's much easier than it may appear. For instance, first you need to read the header, decrypt the header, and obtain the master key. This is quite easy way, and you need 1 afternoon if you are an experienced programmer. Then TrueCrypt uses something called libfuse, which is a user space file system library. So you can implement your own file system using this library, and it's quite easy. It's just you have to implement the interface for actual file operations. You may know that mounting the files is not possible. You have to create the block device, and LO setup just does that. And I am really not sure how it works on Windows, because I don't use Windows, but on Linux, this is quite straightforward. And I believe if you are an experienced developer, you can implement this really easily. And I will show you the proof for that. Next, I need to mention that on Linux, you can replace the steps 2 and 3 by a DM setup, because very surprisingly, the data format is very similar. For instance, on Linux, there is the most used disk encryptor is Lux. It's Linux native, but the encrypted data format is the same with TrueCrypt. So TrueCrypt actually calls a DM setup in the new versions to actually create the block device, which maps the encrypted data to unencrypted data and creates that device by DM setup. So this makes it much easier. Or instead of calling DM setup, you can use libdevmapper, which does the same, but just calling the library function. And now I would like to spend a short time on VeraCrypt, which is actually the follower of TrueCrypt. And on this slide, you can see that VeraCrypt has 80,000 lines of code written in C++. It's based on TrueCrypt version 7.1a. It's TrueCrypt compatible. As you may have seen, it replaces true in header, the magic word which identifies the header by Vera. Again, it's just a minor change. It implements many new ciphers. So now there are 15 new ciphers. It increments number of key derivations, because when you derive the master key from password, you need this operation to be quite time consuming to make a brute force attack less easier. You can even parameterize this number of iterations. It fixes minor issues discovered by the audit. Well, it was just a couple of fixes, not lots of work. And yeah, I should mention that paranoia doesn't mean security, because now, if you remember what I was telling you about how Veracrypt decrypts the header, now you have 15 different cipher algorithms, and you have 5 different hash algorithms. They increased the number of they decreased the number of iterations for the master key derivation. So now, when you try to mount your file system in a Veracrypt, it has a lot of work to do. So it may take a really long time to mount your file system, which may be annoying. And I don't think this is secure, because it's just annoying, and annoying things make the everything less secure. And the question is, if you should donate a project, I think we can ask this question at the end of my presentation. So this is a kind of recap that I should also mention that Veracrypt and TrueCrypt uses UI libraries called VX widgets, which is quite a big library. And when I told you that the Veracrypt has 80,000 lines of code, with VX widgets it would be more than twice as much lines of code. It uses Fuse on Linux, probably on Mac. I didn't check that. I think it uses libfuse on Windows as well, and it uses devmapper on Linux. So this is for a recap, and you can check those links to see what actual ciphers and hash algorithms TrueCrypt and Veracrypt can use. And now I'm going to the most interesting part of my talk, and it's the alternative implementations, because it's quite surprising, but as I told you, that implementing disk encryptor is really not a difficult task. There are actually 2 implementations, and first is typical crypt setup, which allows you to create and mount TrueCrypt drive on Linux. And there is another implementation, which is tcplay. It was implemented by one guy, and it's a really great piece of software, which I took and create a fork. You can check my fork on this link. And tcplay is, as I said, it's a TrueCrypt reimplementation. It has just 6,500 lines of code in pure C, which is great, because actually a shorter program means it's much less lines to verify against the big Veracrypt, which is huge. And it uses device mapper. And maybe you may have heard about Linus Torvalds and what he said about libfuse. Basically, he didn't like it, so it uses just device mapper on Linux. About the complexity, I was already talking, and on Linux, yeah, it replaces Fuse by a DM setup, and actually I created a branch for you in yeah. If you check out or clone my Git repository, you can try to mount. You can create and mount your drive, and you can just run TC play, and it will print as a debug output the DM setup command, which would mount your drive. So it's kind of presentation that it's quite easy to implement such thing, and it's quite interesting. It uses a lib dev mapper where TC play actually calls DM setup directly. So this is another improvement. So what I have done to TC play, again, you may check my source codes, and I implemented new Camellia. Camellia is a Japanese crypto standard. I put Argon 2 derivation hash algorithm there, which is a key derivation algorithm, which is GPU proven. It means it needs a lot of memory to calculate the master key. I removed the tail. Tail in a TrueCrypt is something I don't like, because it's just a backup of the header, and it's mentioned that if you broken your header, you should still be able to mount your drive because you have the tail which you can use instead of a header, because it's a backup. But let's consider that you are sitting in your house, and you have your hard drive, and you have something really secret on your hard drive, and now you see through the window that the authorities are coming, and they are going to bust you and going to torture you, and they wanted to reveal your password. It's obvious. And what you at this moment want to do is you want to wipe your hard drive. And now let's think a little bit about what you would do to actually wipe your hard drive. You can take a hammer and hit the hard drive with a hammer, but hammer is in your garage. So what command would you use to wipe your hard drive? So actually, the very first thing what I would do is to cat def urandom to the device. It would wipe the header, but since the hard drive is huge, it's a 1 terabyte hard drive, it wouldn't wipe the tail, because I have no time for that. So the authorities may capture my laptop and then use the tail to recover my laptop partially. Yeah. So I think having tail on the hard drive is not a good idea for this purpose. And the last thing I have done to this project is YubiKey support. YubiKey is a small stick. Yeah. If it was live, I would show you the keys. I think it's quite popular way how you can store your secret data to using those USB sticks. And yeah, so if you clone my repo, you can see that I implemented this support for those YubiKeys, and it may be interesting for you to look at the code. And let's talk a little bit about the audit. So if you check README in TC Play, this guy who was implementing actual TrueCrypt format discovered many things. And first, he discovered there is a lot of mistakes in documentation. And even if the audit was not mentioned to discover mistakes in documentation, it's quite strange, because this is the sentence from the audit where they recommend to use the documentation. They just documentation does a very good job at the both describing TrueCrypt functionality, but there are if you look at the VeraCrypt web page, there are still those mistakes which are inherited from a TrueCrypt web page, which were not discovered by the audit. This is quite weird. Second thing is the audit didn't discover that in VeraCrypt and TrueCrypt and nobody is using mlog. So in case you have getting out of the memory, it may happen that the swap is used and your password can be swapped to the storage and can be revealed. So this is one thing that I discovered, and it was not discovered by the audit. And the last thing, I was talking about the tail, and the last thing is VX widgets, which is big library, and nobody mentioned VX widgets in the audit. So I think VX widgets is one thing which needs to be audited. And if you look in the current VeraCrypt, it may appear that it's being developed, but actually it's not true. Because if you look at the commits in VeraCrypt, you may discover that what they are changing is they are improving the UI, they are improving localization, but there are very little new features they are implementing. Okay, so very last two.
Sorry, literally last two slides. I'm really sorry, but we just have to, in the next 1 or 2 minutes, wrap it up so that Lukáš has some space as well. But it's super interesting, so carry on. I just want to let you know.
Yeah, so very first, very last two slides are about YubiKey, which is about the implementation. And I think I have no time to talk about it, but I really encourage you to check my implementation and check the YubiKey documentation about what features are implemented in YubiKey and how what ways you can use it. Because people use it just for authentication on web services, but it has many more features which you can use, and there is the list of the features, and I'm not sure if I have time to talk about them deeply. Yeah, those are the major features which I implemented in my project. So I encourage you all to check that, and you will learn many things. So this is the end of my presentation. I am afraid I had a little less time than I expected, but hopefully it was interesting for you. And if there are any questions, and especially if we have time to answer those questions, I would be lucky to answer them.
Thank you very much. No, the presentation was awesome. And I actually have a question, which is relates to your slide where you had MAG ? And I was talking to a friend of mine who deals with embedded systems in a private healthcare facility. And he was and he uses like his whole life he was on either Windows and now switched to Linux. And he was saying that one of the things, because I was always wondering how real technologists always see Macs and they're like, vade retro satana, so I don't want to use it. And we had this really interesting conversation where he said there's user friendliness that, for example, Apple takes to the Macs, but it takes it to the Macs and therefore even makes some decisions about security and how to deal with data on your behalf, so that you don't have to bother with it because you may not have technological prowess. It makes those engineering and encryption decisions on your behalf. And I was wondering, to what extent is that a threat? Because Windows is going in a very similar direction, is that they're simplifying things for the end user and therefore basically wrapping up the code and everything that sits underneath and simplifying it and in a certain way making it much more static. Linux allows you much more control over the whole operation system and allows you much more control in general. Windows and Mac are taking that control away from end users. Do you see that as a potential threat in terms of like how in charge you are of your own data, your digital footprint, your digital destiny?
Actually, I'm not a security expert, and this is just my hobby. Actually, every Czech is security expert, but I'm not. So what I'm going to tell you is just my opinion. And for instance, when you encrypt your hard drive on Mac, you use your user password for actual encryption. So when you log into your Mac, your password is used, which means you have to use a very secure password for logging to your Mac. And this is the problem because on Linux, first of all, Linux is open, so you can verify everything. Mac is not open, so you can verify that. And this problem is what I see is on Linux you can enter the password for encryption, which is different from your actual login password. And using a very strong password for every time I need to make to sudo myself, it's very inconvenient. And not sure if I'm answering the question.
No, you absolutely are. And actually, this is one of the things that we were discussing as well, the way that, for example, Mac makes even password storage very easy. It's all heading in a direction where some of my techie friends are very like concerned about like the oversimplification of the technology for the user and the implications that has for embedded security. So you absolutely answered the question.
But anyway, when they ask you for a password, they use the password to encrypt the hard drive. So when you turn off your computer, then you are safe. Yeah. The question is if you are really safe, and you can't verify that because the system is actually closed. You can't check the source code as I checked with TrueCrypt.
Exactly.
Yeah.
Exactly.
So this is the problem. But as far as I know, nobody managed to break the Mac security. So even if I don't know FBI or CIA can break your hard drive or break the encryption, they wouldn't tell anybody. So
yeah, fair play. Well, thank God we have caped crusaders or like Batman and similar superheroes. Batman's my favorite superheroes, like you and Yiti and Lukáš looking after our safety while we sleep soundly in our beds. Thank you very much. That was very enlightening. And on that front, I would like to invite Lukáš, who I would also like to say is extremely kick-ass, because while he wanted to stay a strong patriot at the start and do it in Czech, he's now going to do the talk in English. So that is amazing. Lukáš, thank you. Lukáš will be talking about also obviously the theme of embedded security, specifically about access management and the delegated authentication. He's from AMI, which is a fascinating company dealing with cybersecurity, identity and access management, and also things like privileged access management. I will leave it to you. I'm looking forward to your presentation. Take it away. And in the meantime, if you have any questions, ask them, because you have the unique opportunity to do so before these gentlemen disappear forever. Thank you.
So hello everyone, my name is Lukáš Kraus. The first question is, do I share my screen right now? Am I sharing?
We can't see anything yet. Aha, yes, it's doing something. Yes, perfect, thank you.
Great, so it should work now. Okay, so I'm from AMI. I'll be talking about access management and single sign-on and delegated authentication. first thing to clarify, some people just say, hey, we got IDM, we got something that takes care of everything like that. Well, that's not true. Let's just clarify, access management and identity management is not the same thing in terms of authentication that you do in access management. So you know that Lukáš Kraus is really him and it's not some imposter. And IDM takes care about authorization. So if you really know that you are Lukáš Kraus, then you take care of stuff he can see. Access management does something that is invasive in terms of application alteration. So if you want to implement central authentication system, you have to actually alternate something in the application that it does not authenticate the user by itself, but it redirects you somewhere else. IDM, identity management, does not do anything from that. And because of that, access management system is critical for your company or anybody else, because if you can't log in, you just don't use the application. You cannot do anything. If you don't have running IDM, it's not so critical because you don't update stuff, but everything that is there is just working. And the last thing is that access management takes care about single sign-on. So you sign into one application and the second application automatically recognizes you and you don't have to input name and password, some second factor authentication again and again. If you have two applications, that's not really a big deal, but if you have 100 of them, well, it kind of gets tedious. IDM, on the other hand, takes care of having a single password, single identity across all systems. So we are not going to talk about IDM. We are going to talk about the access management by itself. Now, let's look at a company. Just a single one, a small one. You have some application. It's the blue rectangle. And you just connect it to Active Directory because the application is made like that. So you don't have to store user access codes and user information in the application itself. You just use the Active Directory, and if a new guy comes in, you just make a new user in Active Directory and just make that user an application user as well, and he just gets one login, one password, and everything works. The time goes, the company gets more and more applications. It can be 4, it can be 40, it can be even 400. Applications are developed by many companies. Not every one of them can be implemented to Active Directory. So then some applications start making their own databases regarding to user access, usernames, user passwords, and stuff like that. That's not good, because if some security guys comes to an administrator and asks, hey, how about that guy that just got into the company 1 month ago? What applications is he using? How many times did he log in? And to what applications at what time? And that's a nightmare for the administrator because you can't really tell. There is no central administration. There is no central logging. You just have to go application by application, just look into the logs and get everything out. So there is a way to centralize that. Well, that's the central access management. Let's say we have the same company, the same applications, the same user databases, but then we implement the central authentication system, the access management. Every application does not care about the authentication by itself. It just redirects the user to the access manager. And the access manager just looks up who the user is, sees if he can use the application, if he has put the password right. It can manage stuff like second factor authentication. It can be an SMS code or something like that. If you actually want to change things like, hey, company does not have second authentication method and you want to add it, Then, if you have central authentication system, you just can add it centrally to every application. And that way, the applications, if you want to add more applications, you just connect them to the access manager and everything just works. The security is done right. Everything is logged centrally. You can manage it centrally. I think everybody is happy. You just have one system that takes care of everything you want. And of course, as we talked about in the beginning, this system is pretty critical because if it does not run, nobody can get into the applications. Delegated authentication is something that most of you already seen, not in the companies, but in the, let's say, normal world. Some applications that you use online just does not ask you for your name and password. You can just see something like, hey, continue with Google, continue with Facebook. And if you click it, what does it mean is that you just make the application look up to Google, you log in through Google, and then you share your Google information with this application that you want to use. And that way, you can be sure that the authentication is done right, if you trust Google, that is. But, well, let's say if you want to change something, for example, you stop loving Google, you go to Microsoft or something like that, then every application that was logged in by your Google account, you will have to somehow change it. So it's up to you. We have something like that in Czech Republic as well. If you want to talk with government online, you have some authentication systems that can be trusted and are trusted by government. So you've got some options. It's mainly up to you if you want to use them or just use a paper and go everywhere by foot. But this is still the same. This is still the delegated authentication because the application that you want to get in does not handle your username and password, certificate or whatever. It just asks somewhere else. For example, Moje ID is really great because you just authenticate to it once and then you can use it for all sorts of stuff, not only from government, but many Czech applications are implemented to it as well. Those acronyms, OAuth, OpenID, SAML, are how it works, are something that you should Google if you want to know how it works internally. We certainly don't have time to deep dive into each of those, but well, most of you can use Google, so I think it's up to you. Let's just see how it works a little bit, not related to one SAML or OpenID or something like that, but how it works just from a user point of view. You can see that user just types application.cz into its browser. The browser goes there and asks for stuff the application has to show to the user. And the application says, hey, I don't know you. You don't have any session cookie or something like that. And I don't do the authentication stuff thing. So I'm gonna redirect you to the access management. There goes the redirection. As you can see, there is no interaction with the user. The browser just goes there. And the access manager, because it doesn't have session ID as well, but the access manager knows about the application, it just presents the user with a normal login screen. So the user authenticates, just puts in login name, password, whatever else you want. And then if everything's right, the access manager creates a session cookie for the access manager itself. So now you have a single sign-on session cookie. And it redirects you back to the application. It somehow takes the data. It can be by HTTP post request or something like that. And it tells the application, hey, now I have the single sign-on session cookie, so I can authenticate to the application. And yeah, the application makes a session cookie for itself as well and says, okay, I know you now. So here is the data you requested because you have tried to see them. And then the browser just shows the data that, that the user requested. As you can see here, the user just types in the application.cz. He has to type in the name and the password, and then he gets presented by the data. So everything else is working under the hood for the user. So that's something that you really want to do like that, because if you implement something that is good for security and for audits and everything else IT related, you have to think for the user as well. And I think this is the way to do it. Now let's see how it looks like if you use the single sign-on. If the same user that is authenticated in the application 1 wants to authenticate in the second application. He just goes to the application, it redirects him to the single sign-on, to the access manager, and the access manager says, hey, I know you, or you got the session cookie already, so he redirects you back and it logs you in the application. So the user just doesn't have to do anything. He just clicks on the application icon or just types in the address, and that's it, he's in. Everything that is happening is under the hood for the user, and everything works fine. If you like open source, CAS is from Apereo, is something that does the central authentication, because it's a central authentication system. I think it's something that if you want to look into it deeper, this is something you can play with because it's open source, and even universities just use it, some companies and as well. And if you want to work on stuff related to this, I think you can look at AMI and see how we do it. You can just work on projects like this with us. So thank you for your time. Do you have any questions?
Thank you so much. I have a question. I actually, and this is a long time ago, I used to work in a company that used to work in digitalization of politics, and we were subject during several elections to DDoS attacks. And it was during the time that GDPR was coming in, and a lot of our clients were very confused about how to, on one hand, educate their employees, and on the other hand, properly encrypt and secure their systems. Maybe it would be good to like demystify security for the general public. Like, what are the biggest threats out there that could realistically happen to me as an individual or a company that really wants to protect its data?
Well, the first question is, what is security by itself? It's not about securing data to not let somebody have them, because there's always a way to get to the data. It's about making the bad way, the hacker's way, much more complicated and costly than just logging in as a user. And if you do the security right, and a lot of big companies do it right if they spend the money, it's not about the system itself. It's most of the time it's about the user. So phishing is the way to go today, because users are not really well. They don't know what they can or cannot do, and most of the time, if something is hacked, it's because even some administrator got phished into clicking to some link, and then the hacker got in. So it's not really it's not mainly about the security of the system. It's about security of the people.
Thank you very much. Yeah, it's interesting to see it. For people, it's a hard concept to imagine, but when you start talking about things like cryptocurrencies and having it on like a hardware wallet, or like just making sure that your money doesn't get stolen from you, suddenly people realize, damn, like they're very happy psychologically sometimes to give away data, to send it to random servers. But when it concerns money, then people start realizing the complexities of that. What would you advise to students then on FIT ČVUT right now? Because obviously, Jiří does amazing work in terms of the research and the applied side of embedded security and working with embedded systems, but the students need practice. How do you think that they can start engaging in putting what they have learned to practice before they've left university? What can they do to really understand the subject on a deeper level?
Well, I think working with companies that do the stuff in big corporations is one way to go. I think we live in a great time where you can look up most of the things on the internet related to how stuff works. So if somebody wants to educate himself, he just can look it up. Most of the stuff is just freely on the internet. You just Google it up, you just read it, and you can even find some funny Indian guy videos that just do the thing you want to do. But if you want to practice, I think you should connect with people that do it for money, because those people are really concerned how good job they are doing.
Thank you very much. So, ladies and gentlemen, the first talk of the day is drawing to an end. We've heard from Jiří Dostál, who showed us the wonderful versatility of the RFID lab and the work with embedded security that they do there. We've also heard from Ondřej Holeček about encryption. We chatted about Macs and Linuxes and all that jazz. And finally, Lukáš Kraus also showed us the exact flow of data and told us a little bit about how you as students can get involved in, I want to say like ethical hacking, but it's more understanding the whole technological ecosystem, the hardware side of it, the software side of it, and everything in between, to start understanding it as a holistic bit of nature almost, because the digital world is becoming very complex. Bits of it are becoming rusty and old, and they're very badly protected. Bits of it, the newest ones, are so user-friendly that it's actually incredibly difficult to get to the source code and understand what the hell is going on. So taking this healthy punk approach and kind of seeing it for what it is and approaching it with a healthy sense of skepticism and multidisciplinarity is very, very important for the future of embedded security. And I would actually like to quote Jiří Dostál from last year's COFIT, if you don't mind. It's not verbatim, but I remember that he said that Czech people are actually fantastic at ethical hacking, penetration systems, etc., because we're a nation of innovative punkers. Like, we like to break things, we like to play with things, and I think that this vertical is something that Czechs will excel in on the global stage in the coming years. So it's really, really wonderful to see this group of gentlemen here talk about the latest breakthroughs and research of the day. Thank you again, Jiří, Ondřej, and Lukáš. It was a very fruitful discussion. We will allow you to go have some lunch now, and we are continuing after lunch at 1 o'clock with a talk on, let me just have a look because my brain is swarming with all the technology and I want to make sure I get this right. Yes, the monitoring of IoT, robotics, and continuing with embedded systems. We're actually even going to be discussing autonomous robotic systems such as smart lawnmowers. So lawnmowers are the way forward, and not just that, we'll also be hearing from Cessnet, Jaké, but also Tomáš Čejka and Miroslav Skrbek will be telling us about the laboratory of network security and everything that happens there, and the network operations called Netmon, and also the lab of embedded systems called Lives, and all the work that happens there. So join us after the break at 1 o'clock Central European time. And thank you again, gentlemen, for being with us here today. Bye.